It may sound unexpected, but how long could a nuclear submarine last in space? Here's a spoiler alert, not very long, but the reasons are likely to surprise you. Unlike what you might think, the submarine wouldn't just explode or fall apart into pieces. Submarine hulls are built to withstand insane pressures, between 50 and 80 atmospheres of external pressure from deep ocean water. So it's quite easy for them to contain 1 atmosphere of internal pressure in space. Then there's this thing. Watertight seals aren't completely airtight, but submarines can keep the water out under immense pressure. It means that air wouldn't be escaping into space too quickly. In other words, your submarine wouldn't leak air all over the cosmos. Okay, how about carbon dioxide buildup? Surprisingly, it wouldn't be an issue either. The thing is, submarines use CO2 scrubbers that can run for a long, long time, as long as there's power. But oxygen is another story. In usual conditions, nuclear subs extract oxygen from water. In general, one can easily imagine a device that will work like plants. With the help of external electricity, oxygen will be released from carbon dioxide. Overall, this doesn't seem like a big problem. But if we didn't add such special devices to the submarine, it would only have enough oxygen to last a few days. Then, this supply would run out. But even before that, a bigger, more immediate threat would arise: overheating. Most people are sure that space is insanely cold, and that's partially true, but it should be noted that it is one thing to interact with something slightly cold but conducts heat well, and a completely different thing to interact with something very cold, but without the ability to give off heat to it. It's like touching metal and foam. The foam will feel warm regardless of its temperature. Space is similar. It has an extremely low temperature, but it might feel very warm. So, without air or water around to absorb and carry away the heat of the submarine, it would only be able to cool down through radiation. For normal space stations, this is not a big problem. For this purpose, stations like the ISS use special coolers that radiate energy into space. But this method is only sufficient for cooling small heat sources at space stations. But submarines generate much more heat. They simply aren't designed to operate in space. They have to cool down with the help of seawater. But in orbit, there's no water to carry away the heat. So the heat generated by the submarine, especially from its 200 megawatt nuclear reactor, would become a problem very fast. You see, civilian nuclear reactors are only about 50% efficient, which means that half of the reactor's energy is lost as heat. If the same applies to the sub, around 100 megawatts of energy would be building up as heat inside the sub. It is about 1,000 times more than the total power of the ISS. Without seawater to cool it down, the sub would start heating super fast, and within an hour it'd be too hot for humans to survive inside. And not long after that, the nuclear reactor would overheat and melt down. Now let's say you somehow managed to send your submarine into space, and now you gotta get it out of orbit. How could you do it? To leave orbit, you'd need to slow it down enough to re-enter the atmosphere. Submarines do have rockets, they are just not attached to them. So, theoretically, if you turn those missiles around and launch them in reverse, they could help slow down the submarine. But there, you'll encounter a new problem. Submarines don't have heat shields like spacecraft, and without this protection, the sub would simply burn up on re-entry. And since submarines aren't built to be aerodynamically stable at hypersonic speeds, it would start tumbling uncontrollably while re-entering, breaking apart in the atmosphere. The debris would either disintegrate in the air or crash into the ground at terrifying speeds. Could you survive re-entry inside a submarine? Unlikely. If you somehow managed to strap yourself into a special acceleration couch inside the right corner of the submarine, there would be a tiny chance of survival. But then you'd need to jump out of the wreckage, hurtling toward the ground with a parachute before it hit the ground. You'd also need to disable the missile detonators before trying this stunt. Otherwise, you'd have way bigger problems than overheating. All in all, nuclear submarines are great for deep-sea missions, but absolutely not efficient in orbit. Running out of oxygen, overheating from the reactor, lacking rockets to safely deorbit, obviously submarines are best left under the waves.
Humanity's facing the greatest danger ever. Our sun's fading. In 500 years, the entire solar system will be plunged into darkness and eternal cold. To save our civilization, people begin to build a huge spaceship that will accommodate the population of the whole world inside and go into deep space. In less than 400 years, the construction of the ship is finally completed. The sun is already nearing its end. It's much smaller and cooler, making the climate on Earth cold and harsh. You and the rest of the inhabitants of the planet are going on board the greatest ship in history. The boarding itself began several years ago, before the ship was even fully built. To avoid a multi-billion crowd, an electronic schedule was organized, sending invitations to those whose turn it was to board soon. Several million people could board within a month. The main rule is to travel light. You bring 2 sets of clothing, personal hygiene items, a phone, headphones, and your favorite book. You arrive to the boarding site and see a huge ark the size of a large island, twice the height of the Empire State Building. Around the ship, there's a huge city clinging to its walls. Construction workers and engineers have been living here for decades. You're standing in a long line, one of 100. Access to the ship is granted to those who have a valid ID. The ID is linked to that person's resting area. One person is given 20 square feet of space. There's a bed and a nightstand inside. Of course, there would need to be much less space if people would just lay down in sleep capsules and flew to a new planet. But no planet suitable for life has been found yet. So, the ship is going to be your home for a long time. Much of the ship's space is occupied by the engine room. Huge power generators and powerful engines will support the long-term movement of a heavy ship in outer space. At last, the boarding and settlement is over. The engines are starting. A voice is coming from the speakers throughout the ship, counting down from 10. These are your last seconds on Earth. The Ark takes off, burning down the whole area it was standing on. People look down at their receding home with sadness, but it's replaced with hope as they turn their gazes to the skies. The whole ship is divided into 200 large sections, varying in size. Each section is a country. Despite this division, the rules on the ship are the same for everyone. Generate energy, keep the peace, and help each other. The energy is produced by exercise bikes. A person pedals and generates kinetic energy that fuels the engines. This is everyone's daily duty. For at least an hour every morning, you take an exercise bike and work out, ensuring normal operation of the ship, maintaining your physical activity, and reducing stress. Then you eat and go to work. Here, just like on Earth, you pass by shops, libraries, and cinemas. The currency is unified for everyone on board. With the money you earn, you can move from your small cabin to a larger one. And of course, just like on Earth, some people easily get a lot of money, while others work 24/7 for a penny. This inequality doesn't bother you so much as it used to, though. People of the future have learned to appreciate peace and quiet, so no one risks to fight in the limited living space amidst the black void. Throughout the ship, there are nature zones. These are small botanical gardens that are grown with the help of artificial light. Plants give oxygen to the ship and help people feel more at home. Water reserves are large, but still limited. To help conserve it, people process their bodily fluids. They're collected in special tanks, filtered, carefully purified, and then sent back to the drinking and technical water vessels. Every person turns over 50% of their waste into water. Fresh water is replenished from space itself. Once every few years, the ship approaches a planet. With the help of scanners and X-rays, geologists find underground rivers or lakes. Then they send a drilling rig there, pump out the necessary amount of water, and pull it back to the ship. Unfortunately, there's nothing useful on these planets except water. Most planets don't have an atmosphere and are unsuitable for human life. People are looking for a place with ideal conditions. They're looking for the Earth's double. With the help of modern food technologies, scientists have managed to replace natural vegetables, fruits, and meat with artificial ones. Real apples or potatoes are also available, but they're rare and extremely pricey. Now, the ship's been plowing the expanses of space for several decades. People are used to their new way of life. Children are born, generations change. The kids born and raised on the space ark Listen wide-eyed to stories of old people about how beautiful life was on Earth. But with every passing year, fewer and fewer of those who remember their home planet are left on the ship. The Ark's children are slowly coming to accept that the ship may remain their home forever, but they still continue to search. Scientists use powerful telescopes and equipment to explore space, and every day they seek potentially habitable planets. Still, nothing's nearby. The most promising worlds are thousands of light years away from the ship. Meanwhile, the peaceful spirit of the first generation of Ark dwellers is gone. People begin to break the rules, and discontent is growing. Not everyone pedals the bikes now, and power failures become more frequent. Social inequality is a burning issue. Some parts of the ship have turned into slums, while others have grown into abodes of luxury. Equipment gradually wears down, making it difficult to extract water, and most plants in nature zones wither because of the clogged ventilation systems. To save more energy, some parts of the ship are cut off from air and electrical supply. People who lived in those areas have to move to the central part of the ship. The already cramped space becomes even stuffier, and with the lack of personal space comes growing irritation. Soon, it becomes obvious there's no other way out but to create a faster-than-light engine, or FTL. It would require major refurbishments and changes to the ship's structure. The matter is up for a vote, and surprisingly, not everyone agrees. Some people don't want to take any risks and are already used to considering the ship their home. They want to use the ship's resources for global repairs. People's opinions are divided. Conflict is inevitable, and humanity risks disappearing from the universe. Resolution comes, unexpectedly, from impending danger. It turns out that the ship is heading towards a wide and unusually dense asteroid belt. The celestial bodies are packed so tight they leave hardly any space for the ship to maneuver. A collision at the current speed is inevitable. The only hope left for humanity is to go all out on building the FTL engine. The work takes months, but it's united people once more. Everyone works around the clock and only sleeps as much as they need to regain strength. While half the people help build the engine, the other half pedal the bikes to generate energy. There's once again a glitter of hope that humanity will be able to find a new world with enough space for everyone. The risks are sky high, but there's no choice. The energy is only enough for a single attempt to jump. If it fails, humankind could be stranded in outer space on a broken starship. Before the jump, people send a capsule with information about humanity into space. They upload videos, movies, music, and the entire history of humankind onto several massive hard drives. This is the only chance to leave a small footprint in the universe if they don't succeed. Everyone is ready. All power is transferred to the engine. People lie down in small capsules and put on oxygen masks. Theirs is a single desire: to wake up in a new world or not at all. No one's ready to watch the fall of humanity. Capsules are locked. People close their eyes. The engine is on. The countdown begins. 3, 2, 1, jump.
Traveling to space costs a fortune, but there's a way to make it affordable. You step into an elevator, push the button, and voila! You're flying to the stars, all thanks to nanotubes. But then something hits the elevator on the way. You're stuck inside, and now you're doomed to float in space forever. Now, if you want to travel in space, get ready to shell out around $55 million. But in the near future, you'll probably be able to travel to space with just the push of a button without breaking the bank, because space elevators might come into play. While the idea of galactic lifts seems like something out of a sci-fi movie, it is a real possibility that could revolutionize space travel. With an estimated cost of $8 billion, space elevators could be a one-time investment that would last us forever. NASA alone spends around $2.7 million on rocket fuel per minute. To launch a rocket, they need to pay up to $178 million. These costs could be significantly reduced with the use of elevators. Most super tall buildings on Earth have a massive foundation to help with their balance and weight. As you look up, they get thinner and thinner. Even the tallest building in the world, the Burj Khalifa, is massive at the bottom and narrow at the top. If we wanted to construct something like a gigantic lift, we would need an enormous amount of concrete to build a foundation for it, which goes against the point of saving some cash. Now, get a string, tie a ball at the end of it, and start spinning it. The string in your hand will stay in one place, and the ball will revolve around your hand. This is called centrifugal force, and the elevator will work in the same way. The ball will be the base in space, and the rope will hang toward Earth. The station from where we would enter the elevator would be in the middle of the Atlantic Ocean, and the line would extend from there. For this to be possible, the line must be perfectly synchronized with Earth's rotation. Otherwise, it would simply break or wrap around the Earth like a scarf. Also, the orbit the line would be following should be a perfect circle, because the line wouldn't be able to get shorter or extend. A bunch of research has been done using algebra to find the ideal solution. Wait a second, there's a use for algebra? Never mind. Meanwhile, I won't bore you with the math. We'll go straight to the point where the precise distance from the station in the Atlantic to the one in space must be 22,236 miles above the Earth, where the geosynchronous orbit starts. There, the four outward forces are much stronger than the downward force. That's why the station would stay in one place. When you construct a house or a building, you start from the bottom going up. But to create this engineering wonder, we would need to do everything in reverse and start at the top. The main problem here would be the weight. If the line was too heavy, it would disrupt the orbit, and the conveyor dumbwaiter host would not work. So, we need to balance the station in space to ensure it worked flawlessly. Steel is one of the most robust materials on Earth. The cable in every lift is made from steel. But when you need a 22,236-mile-long cable, things can get tricky. Steel is hard to break, but it's cumbersome, and when you have to use a lot of it, problems start to arise. We use heavy steel a lot in construction, but we have lighter materials that might put less stress on the station and eliminate this problem. Also, the line would have to be tapered because, at the end point, there would be close to zero stress. But it would still have to be thicker than really needed due to a bunch of safety factors. At the start, the rope would be around 0.5 inches. After using some complicated math, we can figure out the thickness at the end, which is a number so long I am unable to pronounce it. But believe me, it's a big one. So, steel is off the list. Another candidate is Kevlar, which is 5 times stronger than steel. And if we added such materials as carbon and titanium into the mix, the strength would increase tenfold. The line would have a diameter of around 262 to 557 feet. This is drastically smaller than the diameter of the steel cable could be. The bad news is that doing this is too pricey. So, if we don't find the ideal medium to build a cable, the idea of the space elevator will just be a massive waste of time. If only we had some magically light material with a power of 60 gigapascals, which would have a taper ratio of 1.6. Oh wait, we actually do have this unique material. It's called carbon nanotube. It has a strength of 130 gigapascals, which is much more than we need. Nanotubes are made out of carbon and are 100,000 times thinner than a human hair. This material is solid and has good conductive power, which is possible thanks to its unique atomic structure. We use this product in many things, from batteries to optics, and it can be modified entirely and adapted for more uses. Bradley Edwards is the guy responsible for this crazy idea. NASA was looking for new innovations, and they said, "Don't do anything too crazy and start building a space hoist." I guess Bradley took this as a challenge and started working on the elevator. Edwards wrote a paper about a galactic conveyor. When he published it, he expected many people to find flaws in his work, but surprisingly, nobody did. His work was spot on. He came up with the idea of strapping a nanotube line to a rocket and launching it into space. The other end of the rope would fall onto Earth, and robots would use this rope to climb up and make it longer, so we could start building an elevator space station. After this, the elevator could start transporting everything, from solar panels to tourists. In the future, space tourism could be totally possible. Who knows? We might even go on vacations in space. Hey, looking for some atmosphere for your getaway? Well, don't come here, we don't have any. Oops, probably not a good advertising slogan, huh? Meanwhile, a couple of years ago, we could only create microscopic carbon nanotubes. But as time went on, much more research was done to make them bigger. Now they reach up to a few inches. In 20 years, they could be miles long. Carbon costs $28 per ounce. If we do the math, we would see that we would need around $1 billion to build the lift. Yeah, it sounds expensive, but it's a long-term solution to space travel, and it can actually save us a lot of money in the long run. Now, everything looks perfect on paper. But NASA's main reason why they chose not to go along with this project is that right now there are probably more than 128 million objects floating in orbit, and they might pose a real threat to the elevator. The lift could be made to withstand a few hits now and then, but getting hammered non-stop is not part of the plan. Still, Bradley argues that tons of monitoring devices track space debris. Thus, the elevator could avoid them all. Now, if something hit the elevator or the line somehow broke, the consequences would not be too bad. If there were no passengers on board, of course. If the line got cut, the elevator would simply float away into space, posing no threat to people on Earth. In Japan, engineers are trying to build a space elevator. The lift could be used for space mining, too. We could easily cover the cost of the entire elevator by collecting asteroids, because some of them are made of expensive metals. We could mine them and quickly bring them back to Earth. You wake up and can't recognize your room. That's definitely it, but your desk is on the wall, and the dresser is on the ceiling. It's closed, but you can somehow see every folded t-shirt in it. You wipe your eyes. Nothing changes. This isn't a dream. Welcome to the fourth-dimensional world. Wait, rewind. To understand the fourth-dimensional world, we need to look at the others. So, a zero-dimension world is just a point. Now, if you expand it, you get a one-dimensional world that's a simple line. It only has one measure, and that's length. The creatures living in this world can only move in one direction, either left or right. In general, a dimension is a direction in which an object can move. So now we'll add another line perpendicular to the one we have. We get a flat surface with a length and width, like a piece of paper. The flat creatures that live in a 2D world can move left and right, and now forward and backward. To turn this flat paper world into one we're more familiar with, we draw parallel lines from each corner of the square. Now we get height, the third dimension. The objects of this world have three measures: length, width, and height. They can move in three dimensions: left and right, back and forth, up and down. That's the world we live in. But now we need to figure out where to put the next perpendicular line to get a fourth dimension. It's no easy task, because this fourth dimension, as well as the fifth and 12th ones scientific theories say could exist, are hidden from us because of the limitations of our perception. While we were going through the first three dimensions, we could see that with every next dimension, we expand the possibilities. The objects become more complicated. As inhabitants of a 3D space, we can easily imagine what 1D and 2D worlds are like because they're part of our own. But for residents of those worlds, it's not that easy to understand ours because they're just not able to perceive it. Why? Imagine you're one of these 2D flatlanders and you're living your simple flat life. If a sphere, a 3D object, somehow appears in your world, the only thing you'll be able to see is a dot that appears out of nowhere, and then grows into a longer and longer line, and then shrinks back down into a dot before disappearing. A flatlander could combine all these lines to get a circle. Or, if he could look at it from above, he can't, that would involve height, it would just be a dot growing into a larger and larger circle and then getting smaller. Either way, our flatlander ends up looking at a flat circle, not a sphere. That's exactly what will happen to us if we try to understand a 4D object. We'll see it like a 3D object, appearing, somehow changing, and then disappearing. We wouldn't be able to make sense out of it. For example, let's take a 4D hypersphere and put it in our world. Here's what you'll see. Looks like a regular old sphere appearing, growing, shrinking, and disappearing. Good luck trying to combine the spheres all together to make sense out of its 4D shape. Okay, let's try it with something a little easier. Remember, 1D is a line, 2D is then a square, and 3D adds more perpendicular lines to get a cube. To get a 4D cube, called a tesseract, we connect two cubes. We know that every side of a 3D cube is a square. In a tesseract, every side of it is a cube. This shape looks really confusing, especially if we realize that it's a 3D projection of a 4D object on your 2D screen. Just like the Flatlanders, we're unable to fully understand what a higher dimensional world is like. Even scientists have a vague and limited perception about it. They mostly describe it in complex mathematical equations, not physical objects. But think about it this way. Technically, every single day, 4D or even 10D beings could enter our world, and we wouldn't even know it. Now, if the first, second, and third dimensions are length, left and right, breadth, back and forth, and height, up and down, what does that make the fourth dimension? How about a real-world example? There are 2D ultrasounds that show a flat black and white image, mostly made up of outlines. Then there's 3D. It's basically like a normal photograph you'd see in an album. Things have a form, depth, shadows. Then there's 4D ultrasound. This is an image that's constantly being updated with time. The fourth dimension. Some call it strength, but it's basically space-time, in and out and always. So you wake up in your room in a 4D world. The planet is a hypersphere. Everything around you is as if you lived in a sphere. Your wardrobe is still up on the ceiling, and you need to get dressed. Wait, where are you going? Stay right there. I know you still think the shortest way from A to B is a straight line, but you're in a 4D world now. The shortest way here is through. So just look through your wardrobe, find your favorite t-shirt and jeans, and grab them. That's better. Hey, your roommate is making coffee. Let's grab something to eat too. You could just teleport there, but let's take the long way. No, not the stairs, through the walls and floor. Doors and stairs will probably be non-existent in a 4D world. There's your roommate. Don't be confused, he's okay. Albert Einstein called the 4D universe a space-time world. Here, the past, present, and future all come together. So, like every other object, your friend exists in every moment of his entire life. I know what you're wondering. If you can move through walls, can you move through people too? Yeah, but please don't reach into his head and tickle his brain. That's taboo in this world. Even if it can be done, it shouldn't. Here's another cool thing. You can see people's emotions. See the yellowish shadow around him? It means he isn't in a very good mood. But wait, mentally, you don't need words here. They're too slow. You can reach any person mentally within a moment, even if they're on the other side of the planet. Now, let's grab your sandwich, laptop, some work papers. Oh no, you don't need this bag. Forget it. You have pockets, right? Put it all there. You'll see it fits perfectly. There's endless space. Well, and no reason to take things with you when you can instantly teleport. Forgot your wallet? 1 second. Now you have it. Okay, you're a little late already. Work starts at 9 and your boss is going to be seething. But don't worry. Remember, you exist in any time, present, past, and future. Even though it's 9:12 already, just get there by 9. In fact, let's take a vacation day. Teleport to Rome. See all the sights as they were through all of time and history. Master the Italian language. Where to next? When to next? The choice is yours. You can always travel back and get to your job like a punctual hard worker. And still, life in a 4D world would probably be something entirely different than even my wild imagination can come up with. So, I'll let you finish this story down below. There's a giant ghostly hand that stretches across space. Its eerie fingers are reaching for a glowing red cloud that looks like molten space lava. Although it looks like a scene straight out of a sci-fi movie, it's 100% real. The hand was formed after an enormous star collapsed in a huge supernova explosion. The boom created a new star that is bursting with energy. The energy given off by the star is so big that it caused debris from the explosion to swirl around it. This is what created the supernatural-looking hand. The hand is so big that it stretches a colossal 150 light-years. As for the lava-like structure it's reaching for, that's actually a huge gas cloud. So, while it looks spooky, it's completely harmless, and you can go to sleep tonight without worrying about a giant ghostly space hand scooping you out of bed. There's a bizarre star hidden in the depths of space that seems to randomly flash on and off. It's known as Tabby's star, and its light dims at super irregular intervals for really odd lengths of time. There have been so many theories about what's causing this, from meteor showers to outer space interference. The comet shower idea was quickly debunked. Dust from comets, which would block the light, goes away after a couple of months. Tabby's star fades slowly over decades, so the timing just doesn't add up. It can't be down to planets either, as no planet is big enough to block that much light from a star. After years of speculation, scientists have finally found an explanation for the strange phenomenon. The dimming and brightening are actually a result of space dust. A ring of dust surrounds the star, which often temporarily blocks its light. On day 8 of its mission in 2019, China's lunar rover discovered something really strange on the far side of our moon that caught the attention of the entire world. While navigating a path around a bunch of lunar craters, it spotted something really weird lurking inside one of the moon's holes. It was a colored substance, just like gel, that we'd never encountered before. The curious material was a rich dark green color and glistened like diamonds. After a year of analyzing the foreign substance that measured 20 inches by 6 inches, the scientists finally came to a conclusion. The glistening effect seems to come from glass. In space, it usually appears as a result of lunar impact melts. This means that it's most likely from a comet or rock that has hit the moon and melted upon impact. But while it's likely that the strange substance is just melted rock, scientists aren't 100% sure. This is because the pictures were captured under bad lighting conditions, and there were a bunch of other factors that badly impacted the quality of the images. So, the jury is still out on this one. There's a huge space cucumber floating through the galaxy, and no one really knows where it came from or why it's there. Okay, it's not exactly a cucumber. Or a pickle. It's more likely a super elongated rock. Scientists think it may be longer than half a mile, but only 540 feet wide. It's traveling so quickly that there's no way it's bound by our sun's gravity, meaning that the strange object was formed somewhere outside of our solar system. We don't even know how long it's been wandering through space. It's estimated that it entered our solar system during the Victorian era, but who knows where it had traveled before then. For years, we've been told there are 8 planets in our solar system. 9 if you count Pluto, which got kicked out of the club some years ago. But that might all be about to change. There may be an enormous secret world lurking in the midst of our system, which scientists are calling Planet 9. This undiscovered planet could be way out past Neptune. There are seemingly unexplained clusters of orbits there, and this hidden 9th planet would explain this. The planet, if it exists, would be 10 times the size of Earth, take at least 10,000 years to orbit the Sun, and would sit over 200 times further out than our home planet. This is why it's been so tricky to identify, as it's almost impossible to take a picture of. In 2019, 30% of the area that the planet is likely to be in had been searched. It will take at least another 2 years to cover the remaining area. In the meantime, we'll be waiting on the edge of our seats. No. Strange radio waves are beaming down on Earth, and scientists are baffled. These fast radio bursts are sudden, unexplained, and last just milliseconds. We first picked up the weird signals in 2007, and scientists have been scratching their heads ever since. They appear to be coming from outside the Milky Way, millions of light years away. For us to pick them up from that far away, they must be emitting more energy in a fraction of a second than the Sun does in 80 years. Most of these signals only came once, which would have made identifying them much easier, until this all changed in 2017. In August, A signal was picked up that repeated 93 times, ruling out speculation that the signals were being caused by random one-off events. To this day, we still don't know what's causing the signals. Back in 2014, NASA captured a surprising picture of the Sun that showed that it might like to play dress-up. A brilliant storm of magnetic fields caused the Sun to look like a flaming jack-o'-lantern. Even weirder is that the image was captured on October 8th. It was possible because of something called active regions. These are basically areas of the Sun that have greater levels of light and energy. This is what gives the flaming look in the images. The light forms two eyes, a nose, and a wide, jagged, smiling mouth. Fortunately, this look was just a coincidence, and there isn't a giant pumpkin carving enthusiast lurking in the depths of space. Hey, I want to know, is this a trick or treat? Space fans spotted what appeared to look like a spoon on the surface of Mars. It was half covered in dust. They noticed it after images from a Mars rover had been released. As spooky as the suspicious silverware may sound, it was just a trick of the light. The spoon is just a regular old rock, albeit in a slightly odd shape. The play of shadows in the photo made the object look even more spoon-like. Maybe there's a dish nearby that the spoon ran away with. A cosmic eyeball floating somewhere among the stars is no regular-sized eye. It measures an incredible 660 miles across. One of Saturn's moons, Tethys, has become a bit of a celeb to space fans. The spherical moon sports a large crater that makes it look exactly like a giant interplanetary eyeball. There's even a set of peaks inside the crater that look like an iris. Saturn has a gang of 60 moons in total, and Tethys isn't the only one that looks like a random Earth object. Prometheus looks like a potato, Atlas resembles a pita bread freshly served from a Greek restaurant, and Mimas even looks like some villain's spacecraft. And then there's this. There's a giant cat's eye right in the middle of space. Its official name is NGC 6543, but that's kind of long and boring, so most people call it the Cat's Eye Nebula. And it's actually one of the first nebulas to have ever been discovered. Like other nebulas, it was formed by a star that shed its outer layer of gas. The gas floated off and produced this amazing and intriguing structure. The star fires off this layer of gas every 1,500 years. Each time it does this, it creates a spectacular new dust shell. Hey, don't get me started on gas.
You're hovering about 18 miles above the surface of Earth and enjoying the best view of our planet. Whoa, that's a starfall! Make a wish. And that bright dot that's moving very fast is the International Space Station. And then, the waiter brings you a drink. Wait, why is there a waiter? Well, the thing is, you're on a tourist spaceship, and very soon everyone will be able to fly into space with giant balloons. This is Neptune. It's a round capsule with panoramic windows and a 360-degree view. It can take on board 9 people in comfortable seats, including 8 passengers and 1 pilot. It also has an under-deck toilet. As the manufacturers say, it's the toilet with the best view in the universe. There's also a luggage compartment for tools and scientific equipment in the roof of the capsule, a Wi-Fi connection that will even allow live streaming, and there's a bar with refreshments. Space Perspective, the creators of Neptune's plan to price passenger tickets starting at $150,000. And there's no rocket engines, are there? This thing will go up thanks to a giant balloon the size of a football field. Let's move to the launch pad. Passengers enter the capsule. Engineers fill the balloon with hydrogen. It's lighter than air, so the balloon begins to take off. When the thrust becomes sufficient, the capsule with the passengers takes off from the launch pad. The journey begins. The capsule and balloon go up at 12 miles per hour. That's twice as slow as a person can run, and 2,000 times slower than a conventional rocket takes off. So you won't experience hard overloads, vibration, and noise like you would on a conventional rocket. So you're already at 45,000 feet. It's almost halfway there. This is where commercial airplanes fly. This is the frontier where the weather ceases to exist. No clouds, no wind currents or turbulence, but no oxygen either. You'd need an oxygen tank to breathe here, but the Neptune capsule is airtight, so you keep climbing. You also notice that the balloon has grown up several times. This is because we filled the balloon with hydrogen at 0 altitude. The hydrogen was putting pressure on the balloon from the inside, but the air from the atmosphere was putting pressure on the balloon from the outside. But the higher up you go, the less air there is. Hydrogen continues to pressurize the balloon from the inside, but now nothing is stopping it from expanding. So we need a very dense material that can stretch for the balloon. Humanity launches such balloons with weather probes all the time. They take off and get bigger as they ascend. But at extreme altitudes, the balloon material can't withstand the pressure, and it pops. The weather probe falls to the ground. We don't want the capsule with people to fall, so Neptune won't take off that high. But in case of emergency, Neptune has a parachute for safe landing. It's already deployed, and it's attached to the rope that goes to the balloon. So in case of unforeseen events, the parachute will instantly open, and the capsule will begin its slow descent. The entire takeoff procedure lasts 2 hours, and you reach the 100,000 feet mark. In human history, only about 20 people went to the stratosphere by balloon. The capsule hangs in the air. Now you and all the passengers have 2 hours to admire the curvature of the Earth, take endless selfies, and relax. You can even see a blue stripe over the surface of the planet. That's our atmosphere. And if you look up, you can see the most beautiful starry sky of your life. Because there are no clouds or light pollution from the big cities at this altitude, and you can see the stars in all their glory. For the same reason, we send our telescopes to this altitude. 2 hours have passed. It's time for the descent. This procedure is slow and gentle too. The balloon is lowered. Atmospheric pressure begins to press on it again, and it shrinks in size. The capsule will land on the water. It has a splashdown cone at the bottom for this purpose. This thing will help dampen the impact on the water so that everything happens softly and smoothly. 2 more hours of descent have passed. The Neptune touches the water. Now a ship is approaching the capsule. It takes the passengers on board and takes them to the shore. It also takes the capsule itself on board for relaunch into the stratosphere. But the balloon itself can no longer be used for a new trip. As soon as the passengers touch the ground, their journey is over. The first person to ascend to the stratosphere in a balloon was this Swiss man, Auguste Piccard. He designed this round gondola. It was airtight and could take 2 people on board. The gondola was attached to a huge balloon as big as a basketball court. As with Neptune, the balloon was filled with hydrogen. In May 1931, Auguste Piccard and Paul Kipfer began their flight. As they gained altitude, they discovered several problems. The airtightness of the capsule was bad. Air would escape from the capsule, but they were able to fix the problem. They were climbing higher and it was getting colder outside, but the temperature inside the gondola reached 100 degrees Fahrenheit because the crew couldn't control the air release valve, so they felt like they were in a hot desert. Auguste's gondola reached an altitude of 51,775 feet, only 16,000 feet higher than commercial airplanes fly now. And 17.5 hours after launch, Auguste landed back on the ground. During this and other flights, the scientists collected a lot of data about the wind in these layers of the atmosphere and cosmic rays. He was also the first person to send a radio signal to Earth from such an altitude. Later, Auguste Piccard used the idea of a fully airtight gondola to dive to extreme depths. He created a bathyscaphe, capable of descending to the deepest point on our planet, the Mariana Trench. Even though the Neptune is much more advanced, it still can't fly into space. It's not even close to it. So this is where Auguste Piccard was able to fly to. Here is the maximum altitude of the Neptune, but space much higher. This is the Kármán line, about 62 miles above sea level. Humanity considers this to be the boundary of our planet, so the tourists in the Neptune capsule won't even be able to feel weightlessness. But if you want to become a space tourist and dance in zero gravity, there are a few more options for you. This is a crude, suborbital reusable spacecraft. The journey starts on a regular runway, just like a commercial airplane. Here you can see the unusual White Knight II aircraft. It's as long as a tennis court and consists of 2 fuselages. Because of this, it has a wingspan as wide as a soccer field, and our Spaceship Two is attached right between these fuselages. So, White Knight II takes off like an ordinary airplane and reaches an altitude of about 12.5 miles. Then Spaceship Two undocks and begins an independent upward flight. This small spacecraft is the size of a swimming pool. It's controlled by 2 pilots and carries 6 passengers. Ignition. The rocket engine is on, and the spacecraft begins to gain altitude. The pilots and passengers have reached about 282,000 feet, almost 3 times higher than the Neptune balloon. The passengers were able to experience weightlessness for a while. Then the Spaceship Two began to land. The pilots didn't start engines anymore. They just glided in the air. Then the spacecraft released the landing gear and landed on the runway like a regular airplane. The creator of this company, which owns Spaceship Two, plans to carry out such tourist flights into space more often. The ticket for such a trip will start at $450,000. That's 3 times more than the flight on the Neptune balloon. If that's too much for you, we have another option for flying into space. This is the New Shepard spacecraft. This thing consists of a propulsion module and a crew capsule. It launches just like a conventional rocket: vertical takeoff, fast acceleration, and high overloads. The propulsion module helps the capsule reach a speed of about 2,230 miles per hour. At that speed, you could cross the United States from coast to coast in just 1 hour. The booster rocket climbed to an altitude of 65.7 miles. At this point, the crew capsule undocked and reached an altitude of 66.5 miles. The 4 passengers on board at this point felt weightless for several minutes. At this time, the launch vehicle descended to the ground and then made a successful landing. A few minutes later, the crew capsule began its descent. It launched 3 parachutes for braking. Just a few feet before touching the ground, the capsule makes a quick launch of the rocket engines to slow down completely and make the landing as soft as possible. You can become a space tourist and experience weightlessness on this rocket for only $250,000.
Now in space, inky darkness between blinding points of light does a great job. It hides black holes, gaping, hungry, and scary. Their blackness makes it really difficult for astronomers to find detailed information about these space monsters. When a powerful and massive star reaches the end of its life, it can't just fade into nothingness. One of the most likely scenarios, the star will run out of its nuclear fuel. Then, in a blazing flash of light, it'll collapse under its own gravity. If the star was large enough, it'll turn into a black hole. There's a hypothetical type of black hole called primordial. Scientists have never gotten any real proof of their existence. These holes are insanely old and quite tiny, by black hole standards, that is. Astronomers believe they could appear several milliseconds after the Big Bang. At that time, stars and galaxies weren't born yet. It means primordial black holes probably witnessed the entire history of the universe. By now, the smallest primordial black holes have most likely evaporated away, but the bigger ones can still be scattered out there in space. But how did primordial black holes appear in the first place? In the very beginning, space wasn't the same. In some regions, it was hotter, in others, cooler, and some areas were extremely dense. Scientists believe these dense spots could collapse into primordial black holes. The most curious thing, though? These holes might be so small exactly because they popped up right after the Big Bang. The longer it took a black hole to appear, the larger it was. The mass difference between older, smaller, and younger, bigger black holes was incredible. Compare the mass 1,000 times greater than our Sun's and that of a jelly bean. Now you get it. There was a theory that primordial black holes could actually be dark matter. This matter is believed to make up around 80% of the mass of the observable universe. Astronomers can't see this bizarre ingredient directly since it doesn't emit light or any kind of energy. The idea remained unpopular for decades, but recently, scientists have realized there are many more black holes in the universe than they used to think, and it means the theory might actually work. And the vast and still hidden from us population of Big Bang black holes could not only make up but be dark matter. After all, astronomers haven't discovered a single dark matter particle yet, even after decades of searching. Some scientists argue that dark matter can't be tons of multi-sized primordial black holes. They would collide far too often for this to work out. Others object that black holes might exist in twos. and then a third one can always approach the pair and replace one of the initial holes. After all, our universe is swarming with black holes, and there's no lack of them. This process would repeat again and again, meaning there would be almost no merges or collisions. Primordial black holes might stay in clusters the size of the distance between our Sun and the nearest star. Each of these clusters can be home to thousands of black holes, all crammed together. A 30 solar mass monster of a black hole might sit at the center, with more common stellar ones occupying the rest of the space. Such clusters can be everywhere astronomers think dark matter is. But so far, this is still only an exciting theory, and some scientists don't support it yet. More data is needed. Now, black holes sometimes behave like massive galactic volcanoes. From time to time, they flare up, but instead of spewing lava, they produce enormous amounts of energy, and it makes gaping holes in the surrounding material and gas. A short while ago, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light-years away from Earth. The crater left behind, which was actually a hole punched in the cluster's hot gas, could fit 15 Milky Way galaxies. Whoa! Recently, astronomers have found out that one of the most massive stars in the neighborhood might just have vanished. The star used to hover in space 75 million light-years away from Earth. It's usually too far away for scientists to clearly see individual stars, unless they're really massive, like the one we're talking about. It was gigantic and shining 2.5 million times brighter than our Sun. For the last time, astronomers saw the star's light in 2011, but when they decided to examine it more closely several years later, they couldn't find it. Such huge stars usually go out in an extremely bright supernova, but nothing here, which puzzled the scientists to no end. There's a theory it collapsed into a black hole, and it happened without triggering a supernova first. It does occur among stars nearing the end of their lives, but very rarely. KB 141b is a planet outside of our solar system. At first glance, it's not that different from Earth. It has liquid oceans that evaporate into clouds, condense, and get back to the surface as rain. But instead of water, this all happens with rock. The surface of the exoplanet is covered with lava seas tens of miles deep. The temperature on K2 141b reaches 5,000 degrees during the day. That's hot enough for the magma in the oceans to vaporize into the atmosphere. Then, supersonic winds, which can move at the speed of 1 mile per second, carry this rock vapor to the planet's night side. The vaporized magma cools down, becomes liquid again, and falls as a rocky rain. Well, looks like we're gonna need a bigger bumbershoot. A star in the galaxy GSN 069 might turn into a planet the size of Jupiter in the next trillion years or so, all thanks to the star's regular encounters with a black hole. First, astronomers noticed bizarre X-ray bursts. Those were super bright and went off every 9 hours. After examining this phenomenon, the researchers realized it was a star getting flung in a unique orbit around a black hole, and the flashes they saw were the material being slurped off the star's surface. It happened every time the star darted past its greedy host. Over millions of years, the black hole has already transformed the red giant into a white dwarf, and the process isn't going to stop anytime soon. Astronomers have recently discovered some traces of phosphine in Venus's atmosphere. On Earth, this colorless and flammable gas is often found near microbes. That's why a new theory claims there might be life on Venus. But if there is, it could only appear high in the clouds, because no living organism would be able to survive the planet's extreme environment. Its surface is incredibly dry, with no liquid water, and the pressure 90 times greater than that on Earth's surface. The temperatures there reach almost 900 degrees, hot enough to melt certain metals. So that's a no? Methane, a gas that's usually produced by living things, was found on Mars in 2013. European Space Agency's Mars Express spacecraft detected it in Gale Crater near the Martian equator. This discovery might one day answer the question if there's life on Mars. Asteroid 2019 OK scared scientists by sneaking up on our planet in July of 2019. This rather large rock, up to 400 feet across, appeared seemingly out of nowhere. It traveled uncomfortably close to the Earth, a mere 45,000 miles away. That's less than 1/5 of the distance to the Moon. The Sun's outer layer is way hotter than its surface. The temperatures vary from 10,000 degrees close to the surface and a mind-boggling 1 million degrees in the corona. That's the Sun's outermost layer. The reason for this phenomenon might be nanoflares. Those are regular, powerful bursts of heat from the star. Another theory blames the layer that lies just beneath the Sun's surface. It seems to generate a weak magnetic field. That's why, when the energy from this layer leaves the Sun, it heats the corona through a mesh of magnetic branches and roots. The Moon might still be shrinking. Our planet's natural satellite has become 150 feet skinnier than it used to be several hundred million years ago. If its insides keep cooling, it might explain the quakes shaking the Moon's surface. In 2019, NASA's InSight lander, whose goal was to study the interior of Mars, registered the first Marsquake ever. These quakes were coming fast, about 2 per day. Most of them were tiny. You wouldn't even feel them if they happened on our planet. So far, more than 300 Marsquakes have been detected. Those are the first quakes on any space body other than the Earth and the Moon. Another mysterious phenomenon discovered by the mission was bizarre magnetic pulses. They occurred every midnight around the lander. It's still unclear what those pulses are. Maybe after midnight they're going to let it all hang out, or something. Pluto's atmosphere rises much higher above the surface of the dwarf planet than, let's say, Earth's. It also has more than 20 layers, all of them freezing cold and extremely condensed. Oh, by the way, our Moon also has some sort of atmosphere. Called an exosphere, it consists of helium, neon, and argon. It's 10 trillion times less dense than Earth's atmosphere. Or, really thin.
Venus is often called Earth's evil twin. The thing is, this world once started off quite similar to our home planet. But later, something went wrong. These days, the two planets are relatively close and similar in size. But Venus's atmosphere is very different from that on our planet, all thanks to a runaway greenhouse effect that has been going on for a long time. The surface of Venus can get even hotter than the surface of Mercury, 864 degrees F. And the surface pressure feels as if you're more than half a mile underwater. The thick atmosphere presents its own challenges. Its clouds consist of sulfuric acid, which is used in lead-acid batteries, as well as industrial cleaners. And if you decided to land on the planet, you'd have to survive atmospheric entry, with friction heating you up to 20,000 degrees F. Still, people have always wanted to explore this inhospitable world, and we can't but talk about the Venera program. During the 1970s and 1980s, several spacecraft studied Venus from orbit and from its hostile surface for an hour or so at a time. The 10 successful Venera landers provided us with most of the data we have today about the surface of this mysterious planet, including surface composition, direct measurements of atmospheric conditions, and sets of unique images. At the same time, astronomers got their hands on these treasures, only after a series of annoying failures. They started with Venera 1, launched in February 1961. Each consequent spacecraft was somehow improved and upgraded. But it still wasn't until the 5th group of Venus-bound space probes launched in 1967 that one of them, Venera 4, reached its target and sent data from Venus. Before that, Venera 2 and 3, launched in November 1965, were supposed to land on Venus, but both of them failed in transit. 11-foot-tall Venera 4 was a hefty thing. Its bottom lander was a bunch of instruments and a battery wrapped up in a pressure shell equipped with a parachute. This probe reached Venus in October 1967 and successfully launched the lander. The mother spaceship sent the probe flying over the planet, and it entered Venus's atmosphere. Temperatures were reaching 20,000 degrees F, and the entry force was as great as 450 G. It didn't prevent the onboard instruments from analyzing the atmosphere and sending back data. The first recorded temperature was 102 degrees F, and atmospheric pressure was similar to that on Earth. But the deeper the probe went, the higher the numbers became. 10 atmospheres, 20. They kept going up much higher than engineers had anticipated. 93 minutes into the mission, when the probe was still more than 16 miles above the surface of the planet, Venera 4 cracked open near its top and crashed. At the crash point, the measurements showed 22 atmospheres and 530 degrees F. Scientists realized that they needed a bigger spaceship. After some intense engineering, Venera 5 and Venera 6 saw the light of the day. Engineers did everything they could to make the landing probe stronger, but they were pressed for time. That's why Venera 5 and 6 were not fully prepared when they went on a mission. That's why Venera 5 transmitted data for a mere 53 minutes before succumbing to temperatures of 600 degrees F and pressures of 27 atmospheres. And Venera 6 lasted for 51 minutes. In any case now, the leaders of the project knew what it would take. 840 degrees F, 100 atmospheres, corrosive acids. They seemed to be prepared. They found new materials to build the probe. They got a hotter and stronger test chamber for the trials. They modified the parachute to make the lander fall faster so that the probe could spend as much time on the surface as possible. The lander was also designed in the shape of an egg and made of titanium, so its surface was smooth and had just a few ports, welds, and substructures. The insides were lined with a shock absorber and insulation layer. The chamber was also to pre-chill to freezing temperatures before entry. And Venera 7 was finally a success. It reached the planet in December 1970, separated from the mothership, and went down into the atmosphere. The probe transmitted data for 35 minutes, and things seemed smooth. But then, its chute melted, and the probe dropped like a rock, hitting the ground at 35 miles per hour and bouncing. Then, a second after the landing, the signal was abruptly cut. It looked like the probe crashed to bits. Shockingly, a few months later, while looking through all the data they managed to get, engineers rediscovered the signal. It was super weak and lost amidst the noise. Apparently, when Venera 7 bounced, it misaligned the antenna. The probe rested on its side, which weakened the signal to 1 or 3% of its initial strength. The probe kept transmitting data for 23 minutes. After that, the temperatures got too high and melted its shell. Venera 8, launched in 1972, had a similar design and experienced a similar fate. Venera 9 and 10 were a new generation of probes. They could send back black and white photos. It was actually the probe's main goal, to send the first ever photographic panorama from another planet. Venera 9 and 10 were 5 times heavier than their predecessors and weighed 5 tons at launch. The lander was 6.5 feet tall. It was basically a hermetically sealed titanium sphere that was supposed to hold the instruments. It was bolted with gold wire seals. Inside, there were shelves of beryllium and electric fans, whose main goal was to disperse heat to prevent instrument failure. On the bottom of the lander, there was a shock-absorbing ring. And at the top, there was a titanium ring that looked like a hat. It served as an aero brake. The parachute was supposed to detach at 30 miles above the surface, and the aero brake had to do the rest. In October 1975, Venera 9 and 10 arrived at Venus and landed as planned. Venera 9 was the first to land. It touched down on a slight slope, a volcanic crater or a hill, and kicked quite a bit of dust while landing. One of its 2 cameras succeeded in photographing and transmitting data, and soon scientists saw the first ever pictures of the surface of Venus. It was mostly sharp rocks, soil, and a distant horizon. The sun was slightly obscured by clouds that day. A gentle breeze was blowing. Overall, it was a pleasant morning. If you didn't pay attention to crushing pressure, almost completely waterless atmosphere, insanely high temperatures, and corrosive acids. Venera 10 landed in the same way a few days later, but the terrain it landed on was much more boring. Just a rolling plain with hardened pieces of magma. Both probes transmitted for 40 to 60 minutes until their orbiters went out of range. When it happened, the temperatures inside the probes were reaching 140 degrees F. The orbiters later burned up in the atmosphere after completing their mission. Venera 11 and 12 could have been a success, but a mysterious electric anomaly messed up with their cameras, so their trip was quickly forgotten. And Venera 13 and 14 entered the picture. They had improved scientific instruments and cameras that could take color images, and new heat-resistant technologies were used during the creation of these probes. Venera 13 arrived first and landed as planned. It took 2 photos, one black and white and the other in color. In the photos, one could see a surface of pebbled, loose soil and outcroppings of bedrock. It all looked pretty similar to the surface of the ocean. In the distance, there were rolling plateaus and an orange sky. The images taken later by Venera 14 showed a more weathered plain with less loose soil and fine-grained rocks. The 2 probes also sent back what they heard. It mostly sounded like a gently blowing wind with hints of distant rumbling. Could be Venus quakes. Venera 13 and 14 were the last landers to touch the surface of the planet. Venera 15 and 16 just flew around Venus, mapping its topography from orbit.